My name is Bibi and this is my integrative activity. Okay, to begin with, I was given two compounds. Potassium permanganate, KMnO4, and benzene, C6H6. And I had to classify them as organic or inorganic compounds. Well, I reached the conclusion that benzene is an organic compound. Why? Well, first of all, it has poor electrical conductivity. It also has a boiling point of 80.1 Celsius degrees, so it's a low boiling point. Then, it is soluble in non-polar compounds or solvents. And the rule says that non-polar is soluble in non-polar and polar is soluble in polar. And finally, it evaporates easily. These are all characteristics of organic compounds. Well, also the most obvious one, it's a CH bond. Then potassium permanganate is an inorganic compound. Why? Because it has a relative density of 2.073, which means it is more than 1, so it does not float in water. It also has a melting point of 240 Celsius degrees, which is a high melting point. It is not flammable, it is important, and it is soluble in water. Water is a polar compound, so polar in polar. These are all characteristics of inorganic compounds. Also, there are no CH bonds. Now, for the next question, a student analyzed a substance and got these results. I analyzed the data and reached the conclusion that the substance which was analyzed is an inorganic compound. Why? Well, let's dive in. It says here that it is not soluble in non-polar solvents. That means that it is by default a polar substance. Why? Because polar dissolves polar and non-polar dissolves non-polar. So inorganics are polars. Then it has a very high melting point, 1256 Celsius degrees. It is non-flammable and it does conduct electricity in water. These are all characteristics for inorganic compounds. Finally, I was given this chemical structure along with some questions regarding it. Number 1. What carbons do not fulfill the tetravalence rules and why? Well, the tetravalence rule basically states that a carbon must have 4 links or bonds, whether between with another carbon, a hydrogen, or any other elements. Not more or less, 4. So all we had to do was count the bonds in each carbon. I underline with purple the ones that do not fulfill this rule. Here, carbon number 2, it has 3, 4, 5 bonds, so it does not apply. Here, carbon number 3, you have 2, 4, 1, 5. Remember that this is a semi-developed formula, which means that we have to take into consideration the subscripts beneath the hydrogens. So it does not apply either. Then, how many sigma bonds does carbon 1 have and why? Sigma bonds are the strongest kind of bonds and are between hybrids. So here, in carbon number 1, we have the 2 sigma bonds with hydrogens, and in the double bond, there is a pi bond and a sigma bond. So in total, we have 3 sigma bonds in carbon number 1. Now, what hybridizing is present in carbon number 2 and why? Easy. Here we have an sp hybridizing. Why? Because we have a triple bond. That's the key. When you see a triple bond, sp. Finally, what is the total numbers of carbons with sp3 hybridization and why? sp3 hybridization stands for single bonded carbons. Only single bonds. So all we had to do was count. I underlined the sp3 hybridization carbons with orange. So we have 1, 2, 3, 4, and 5. Notice how I took into consideration the subscripts and the bonds. That would be all for today. Thank you so much.